Everything's fine. Adding and subtracting with radicals. So let me start. Yeah, I know. Allison's like, it's adding and subtracting. How hard can it be? Well, hold my drink. Let me show you. Here you go. We're going to start simple with just the basic concept of something that you already know. Let's forget about radicals for a second and focus on just an expression, an algebraic expression. If I give you 3x plus 7x, you guys know how to add 3x and 7x together. What is 3x plus 7x? 10x. The reason that it's 10x is because of what? Why? Why are we allowed to add the 3 and the 7 together? Elisa. They both have the same variable. We call that like terms. They have like terms. So because of the fact that they are like terms, we can take the coefficient, the 3, and the positive 7. We can take that, add that together to get 10, and then we just keep the like term, right? We keep that x. The x just stays an x. We know that. That is something we learned, well, I mean, you guys learned it last year, and we still continue to do it now. It is something we already know how to do. It's the same exact thing with radicals, but instead of calling it like terms, we call it like radicals. So that's our idea now. We need to achieve like radicals so that we can combine radical terms. And to be a like radical, you must have a common radicand. Now remember, we talked about the radicand. The radicand is the value that is inside of the square root. Okay? Remember, the radicand, that is the value inside of the radical, right? It's inside of that root. So you have to have whatever's inside of your root, it has to be identical in order for you to add the coefficients. What is outside of the root? So let's take a look at an easy example. If I have 2 square root of 5, and I want to add it with 4 square root of 5, I can. If this said 2x plus 4x, I could do 2x plus 4x. So same thing here. 2 square root of 5 plus 4 square root of 5. I can add that together by just focusing on adding the coefficients. I'm just going to focus on doing 2 plus 4. The radical, right, the root that's behind it, because it's identical, I'm just going to keep that. That's the square root of 5. So what's 2 plus 4? 6. So my answer here is 6 square root of 5. It's that simple. We good so far? If the value inside of the root is identical, you treat it as if it's an x. You add the coefficient in front of it, and you keep the radical. Nothing about the radical changes, just the same as nothing about the x changed. The x stays an x. The only thing that changes is the coefficient that's in front, because you added those coefficients together. Try this one. We have 3 square root of 7 plus 8 square root of 7. Raise your hand to tell me, what do you think the final answer is going to be? I'll give you just a few moments because it's really not that hard. This is an easy one. 3 square root of 7 plus 8 square root of 7 is going to be what? Brian? 11 square root of 7. Good. They have an identical radical. They have an identical value inside of the root. So I know that that square root of 7 is going to come down just like an x would have come down. The only thing that I'm going to focus on is doing 3 plus 8. What's 3 plus 8? What's 3 plus 8, guys? 11. So we're going to get 11. 11 square root of 7. Okay, let's take a look at a third problem. It's the same thing with subtraction. If I have 9 square root of y minus the square root of y. Okay, pretend it was 9y minus y. You would know how to do 9y minus y. It's no different than it's got a square root around it. When we don't have a coefficient written, what do we know exists, guys? A 1. When we don't have a coefficient written there, I know that automatically there's that invisible 1 right in front of it. So they have an identical radical. That square root of y is the same for both of them. So I'm just going to bring that square root of y right down. So all I'm going to actually focus on doing is the coefficients. And what do I get? 8 square roots of y. Good. So we're just going to focus on doing 9 minus the 1. 9 minus 1 is going to give us 8. So we get 8 square roots of y. 8 square roots of y. Okay. Sometimes you can't simplify. Sometimes you cannot add. Can I do 2x plus 7y? Why not, Allison? Why can I not do 2x plus 7y? Because x and y are not alike, so they're not like terms. So the same would go for something like this. If I had 12 square root of 2 minus 4 square root of 11, are they like radicals? No. One of the radicals is a 2, the other radical is an 11. So they are not like radicals. They are different radicals. Therefore, you cannot combine or subtract. Okay, let's write that down. Looking at these radicals, the square root of 2 and the square root of 11, they are different. Different radicals. So you cannot simplify. You cannot subtract them. You could not add unlike radicals. You cannot subtract unlike radicals. You cannot simplify it. So your final answer is what the original question was. 12 square root of 2 minus 4 square root of 11. It cannot be done. That's as simplified as it's going to get. Sometimes you can simplify some stuff and not others, all in the same problem. So why don't you guys try this one on your own? Negative 8 square root of 3x plus 6 square root of 2x plus 10 square root of 3x. All right, so we have negative 8 square root of 3x plus 6 square root of 2x plus 10 square root of 3x. Who would like to raise their hand and just share what they got? Okay, so nobody wants to share what they got? So you're going to make me, like, call on people and say, Hannah, thank you, honey. What'd you get? You're right. See, it's not so scary. You guys are going to do fine. All right, so we get 2 square root of 3x plus 6 square root of 2x. How she got that? Let's take a look. Do we have any common radicals, like radicals up here? Malia. Good. The negative 8 square root of 3x and the positive 10 square root of 3x. Those are like radicals because what's inside of the root is identical. Remember, to be a like radical, you must have a common radicand. Means that the value inside has to be the same. This one's not the same because, yes, it has an x, but it has a different number, right? These ones have 3x. This one only has 2x. So this is not a like radical. Doesn't mean that I ignore it. I still incorporate it in my problem, but it is different than the others, which means I can just go ahead and drop it down into the problem. I'm not going to use it, but I don't want to lose it either. We want to keep it here. What we're going to focus on are the ones that are like radicals. So I'm going to go ahead, instead of circling it, I'm going to go ahead and highlight that these are like radicals here. That's square root of 3x. So that's going to get brought down. And what we're going to focus on is the negative 8 plus the 10. We're going to focus on doing negative 8 plus that 10. And negative 8 plus 10 gives us a positive 2. So we get 2 square root of 3x plus that 6 square root of 2x. And then that's it. That's as far as we can go. Everybody okay so far? You guys ready to step it up a little bit more? Oh, too bad. Okay. Come on. Learn to have some, I mean, a baby can be thrown in the water and not drown. Y'all will be fine. They don't. They somehow know how to flip and float. Babies. They do. They really do. There's classes. Okay, well, we're gonna go with that flow anyway. So yeah. So here, number 6, we've got the square root of 12 plus the square root of 27. Right off the bat, I'm looking at them. Are they like radicals? Are these like radicals? Yes or no? No. Looking at them right off the bat, I can tell they're not like radicals, but they actually are. Okay? So I can actually make them into like radicals, because even though 12 and 27 are not the same, they are also not simplified. Square root of 12 is not a simplified radical. And in fact, I can break square root of 12 up. Who can raise their hand and tell me what perfect square goes into 12? Alex. 4. 4. So I'm going to write square root of 4. And what is the other factor going to be then? If 4 is one factor, what is the other factor? 3, right? 4 times 3 is 12. So there is my, I'm starting to, break it down, square root of 4 and square root of 3. And like we said before, square root of 4 is a perfect square. What is the square root of 4? 2. So I have 2 square root of 3. Okay? 27 is also not simplified. Who can raise their hand and tell me what perfect square do we know that goes into 27? Allison? Good. 9. 9 is the perfect square, and she shared with us the other factor. It would be 9 times 3. So 9 times 3 is the 27. 9 is a perfect square. When we simplify it, it becomes a 3. So we get 3 square roots of 3. And don't forget to bring your addition sign down in your problem. All right, now do I have common radicals? Yes. Now I do have radicals in common. Those square root of 3's are identical, so I can go ahead and write square root of 3, and then I'm just going to take the 2 and add the 3. What's 2 plus 3? 5. So my final answer is 5 square root of 3. 5 square root of 3. When you get a problem, you should always try and simplify, break the radical down if it can be broken down, then check to see, can I combine those like terms together? I want you to try this one on your own. We have 3 square root of 8 plus the square root of 45. 3 square root of 8 plus the square root of 45. Break down the square roots because neither one of those are simplified. They both can be simplified further. Then see, could you combine them or not? If you can still not combine them, then your final answer is at least the simplified version of what you did. If you can combine them, you combine them. Okay? Try that on your own. All right? Who's brave enough to share their answer? Philip?
I'm pretty sure the answer is 6 squared 6 square root of 2 plus 3 square root of 5.
Okay. Anybody get anything different? Oh, okay. Allison? (12 square root of 2 plus 3 square root of 5. So we have 6 square root of 2 plus 3 square root of 5 and 12 square root of 2 plus 3 square root of 5. Anybody get anything different than that? Okay. So how did you get 12 square root of 2? And so how did you simplify square root of 8? Okay. What did you do? Okay, so Philip, you were correct. It is 6 square root of 2 plus 3 square root of 5. Good. Always make sure you try and check your work to make sure you catch any mistakes. So that 3 is going to come down in the front. Then we're going to continue to bring it down so that it can get multiplied with that perfect square root. The square root of 4 can be simplified to a 2. And then we can multiply those together to get 6. So we have 6 square root of 2. Okay, then that square root of 45, the square root of 45, we can split it up as well. What are the factors for 45? 9 times 5. Good. So we have square root of 9 and square root of 5. Square root of 9 is the perfect square, so we get 3 square root of 5. Okay, and because they are different radicals, one of them is a square root of 2, the other is a square root of 5, they are different radicals, then you cannot add them together. So this is our final answer. 6 square root of 2 plus 3 square root of 5. You guys ready for another one? Oh, come on. Where's your sense of, you know... See, there you go. Everybody should wear lots of mascara. Boys, definitely lots of mascara, guys. You know. Oh, Omar, it would look so great on you. And then it will keep you guys from wanting to cry because you don't want it to run down your face like a horror film, you know? Yeah. A Twinkie? I don't think I have Twinkies. Aren't Twinkies like the doomsday food? Like, okay, apocalypse is happening, so Twinkies are the only things that will probably survive? No. Twinkies and cockroaches. And canned beans. There you go. Cockroaches will touch the Twinkies at my house. Now, see, when a cockroach won't go near a Twinkie, you know it's probably not a good food for you to be eating. Who cares? I got some at home, I think. Hannah, do you have a question? Oh, yes, that should be 8. Thank you. Thank you. It's an odd little 8 there. All right, so here we've got the square root of 2x minus square root of 8x plus the square root of 32x. Okay, so do you guys want to try this one on your own, or you want me to go through it with you? Help? Okay, that's fine. So let's just start with each little individual one. So let's go ahead and pretend that the rest of this problem doesn't exist. And we just have the square root of 2x. Can we simplify it? So we're going to look at the number first. Can 2 be broken up? No. No. So now let's look at the variable. Can x be broken up? No. No. So can we simplify square root of 2x? No. No. Square root of 2x is as simplified as it's going to get. So what I'm going to do is just go ahead and bring it straight down. There's nothing more that I can do with the square root of 2x. It is stuck here. Okay? All right, so now let's go here. Ignore the minus sign. The minus sign is just part of the problem. We're just going to put it right here. What about 8x? Let's focus on the 8 first. Can I break 8 up? Yeah, I can break 8 up. I can break it up into what 2 factors? Square root of 4 and 2, right? Square root of 2. Okay, now what about the x? Is the x a perfect square? Is it going to go with the 4 because it's perfect, or is it going to go with the 2 because it's not perfect? It goes with the 2. It's not perfect. The x is not a perfect square because it's not an even power. It does not have an even exponent. So it's going to go with the 2. Okay? So when we break up 8x, we break it up as 4 and 2x. 4 times 2x gives us 8x. 4 is the perfect square. 2x is not. Everybody understand? Okay? Now, I'm not going to simplify anything yet. I'm just going to go now to this one. This got my plus sign. I'll put my plus sign here. What about 32? Let's break 32x up. What's 32's perfect square? 16. Very good. So we're going to go ahead and put square root of 16. And what's the non-perfect? 2. Okay? 16 times 2 gives us 32. But we have another x. Is that x going to go with the 16 or with the 2? The 2, because it's not perfect. It's not perfect. So it's going to go with the 2. Okay? So we've broken everything apart now. Again, I cannot simplify square root of 2x, so that's just going to go down as square root of 2x minus, I can simplify that 4, that becomes a 2. I still have that square root of 2x right here. Then I've got my plus. I can simplify the 16 because it's a perfect square. That becomes a 4. And then here my non-perfect square, the 2x. All right. So I've simplified each thing individually. Now I got to check to see, can I combine? Yes, I can, right? In fact, can I combine all of them? Yes. They all have like terms of 2x inside of their radical. We've got square root of 2x, square root of 2x, square root of 2x. However, the first one is the only one that doesn't have anything written in front of it. What should I put? A 1. We've got to put a 1. So that way we know that there is a coefficient in front. So now we're going to take that 1 and we're going to subtract a 2 and then we're going to add a 4. So we're going to do 1 minus the 2. Oops. 1 minus the 2 plus the 4. All of that's going to get done. And then we've got that square root of 2x that's going to lag behind it. Okay, so what's 1 minus 2? 1 minus 2 is negative 1. 1 minus 2 is negative 1. Negative 1 plus 4 is 3. So we're going to get 3 square root of 2x. And then we're done. No, not for the day. Nice try.
Is there homework?
That doesn't mean anything. Oh, well, that's just because he's mean. All right, here's one for you to try on your own. It's not long. It's
difficult.
It's fine. All right. Who's going to share me their answer that they got because they're so awesome and magically smart? So many choices. Jose. Very good. 13 square root of 3xy. Let's go ahead and talk about this one. So let's focus first on the first problem. We have 4 square root of 12xy. The 4 is on the outside, so we're going to go ahead and just place it right down here in front. The 12, we're going to focus on the number first. The 12 can be split up into a square root of 4 and a square root of 3. The x is not a perfect square, so it's going to go with the 3. The y is not a perfect square, so it will go with the 3 and the x. Okay? Everybody clear so far?
Yeah.
Okay. So now we're going to focus on the next one. We have the square root of 75xy. 75 can be broken up as square root of 25, which is perfect. Then the square root of 3, which is not perfect. Both the x and the y are also not perfect, so they're going to go with the 3. So that will give us a 3xy. And now we got to simplify. This 4 that was in blue, the coefficient, is just going to come straight down as a regular 4. This square root of 4 is a perfect square, so we're going to take the square root and we'll get a 2. And then we still have square root of 3xy. The 25 is a perfect square, so we're going to take the square root and we'll get 5. And then, of course, we still have that square root of 3xy. Okay, we still have to continue simplifying. We are not done. That 4 and the 2 that are outside need to go ahead and be multiplied together now. We need to do 4 times 2. 4 times 2 is going to give us 8. So we now have 8 square root of 3xy plus this 5 square root of 3xy. Okay, because they both have identical radicals, they are identical, we can add the coefficients together. We can do 8 plus 5, and 8 plus 5 is going to give us 13. So we have 13 square root of 3xy. Okay? We're going to do that 8 plus the 5 because these are identical. Let's try another one. Just last problem. Last practice problem. We have 9 square root of 75 minus 2 square root of 27y plus the square root of 48y. Okay, try that one on your own. That's the last one that we're going to do for today. Let's go ahead and go over the answers. So, Allison, why don't you share what you got? Because I'm very intrigued now. Because that's all. Because you're right there.
Okay. 45 the square root of 3 plus 10 square root of 3y.
Really close. You had the right concept, except the fact that it was a minus in front of here, which would have made it a negative 6, not a positive 6. So you wouldn't be doing 6 plus 4. You would have been negative 6 plus 4. So it should have been minus 2. It should have been minus 2 square root of 3y. So, yeah, you got to make sure you include the operation that's in front of it. Okay? All right, so let's go over what she was doing. So you got the right concept. The sign in front threw you off to where you got a wrong coefficient. That's all. All right, let's take a look. That 9's going to come out here in front. The square root of 75 can be broken apart into square root of 25 and square root of 3. Then we have a minus, and I'll just go ahead and keep it in the blue, minus 2. That's going to come out here in front. That square root of 27y can be broken down into square root of 9, which is perfect. And then the square root of 3, and the y is going to go with it because the y is not perfect. Then plus, then we have the square root of 48y can be broken down into square root of 16, which is perfect. And then the square root of 3 and that y, because the y is not perfect. Okay, so now I'm going to go ahead and identify all my perfect squares. I've got square root of 25, which is 5. I've got square root of 9, which is 3. I've got that square root of 16, which is 4. Okay, so this becomes 9 times 5 square root of 3 minus 2 times 3 square root of 3y plus 4 and then square root of 3y. So now we got to do that 9 times 5. 9 times 5 gives me 45. So I have 45 square root of 3. And then I've got to do negative 2 times 3, which comes out to being negative 6 square root of 3y. And then a positive 4 square root of 3y. And then here, the only ones that happen to be like terms is that square root of 3y's. The square root of 3y's are like terms, so I'm going to go ahead and bring those down as square root of 3y. And what I'm going to focus on is a negative 6 plus 4. Negative 6 plus 4 is going to give me negative 2. So I get negative 2 square root of 3 right here. That 45 square root of 3, that is not a like term. So it just comes straight down as its own, 45 square root of 3. So here's your final answer. And I'll write it all in one color so it makes it easier to see it. 45 square root of 3 minus 2 square root of 3y. And you're done. Okay? It's a lot of work, but it's not so bad.